Now we're going to look at something called inscribed angles in a circle. An inscribed angle means that the vertex of my angle is on the circle. So far we've talked about central angles. And so these have a bunch of different interesting properties. The first one is that if an angle is inscribed in a circle, then the measure of the angle is half that of the intercepted arc. So if here's my arc, and let's call that x, then my angle is going to be 1/2 x. Now, what's easier, to divide by 2 or cut it in half or multiply by 2? I personally like multiplying by 2. So versus going from the arc to the angle and dividing by 2, I like to go from the angle to the arc. So I prefer to say that if my angle is x, then my arc is 2x. And I write that as 2 times my angle equals the intercepted arc. So 2 times my angle equals the intercepted arc. Also, if I have 2 inscribed angles, so say I have this one, and they are intercepting the same arc, that means that the angles are congruent as well. So if they have 2 inscribed angles and they're intercepting the same arc, the angles are congruent. Which makes sense because you're getting the same arc measurement, so of course when I say divide the arc by 2 to get the angles, I'm going to get the same answer. Alright, because of the nature of your arc divided by 2 gives you the inscribed angle, if I have a semicircle is 180 degrees, so if I divide that by 2, that means that my angle is 90 degrees. So if an inscribed angle of a circle intercepts a semicircle, then the angle is a right angle. And last, if a quadrilateral is inscribed in a circle, that means all the vertices are on the circle, then its opposite angles are supplementary. So, say I have this angle and this angle, the red plus the blue, oh, and these are angles, not arcs, the red angle plus the blue angle is 180 degrees. On the front of your foldable, it just states those properties again, so you can just leave it, or if you want to add on the front, since you'll probably get this more, 2 times your angle equals the intercepted arc, and that might be helpful. So how do we use these to solve problems? First, you want to notice that you have an inscribed angle. An inscribed angle, again, means that the vertex is on the circle. This matters because so far we've talked about central angles and now inscribed angles, and later we will get to secant and tangent angles, so you have to pay attention to what situation you're dealing with. So remember, 2 times your angle equals the arc. So what I'm given is that my angle is x, so 2 times x equals, they're saying BC is 120. Well, is the 120 what I need? Not right now, because what I want, or where I have my variable, is this piece. So now we have to think, well, if I want to talk about the arc that the angle is intercepting, I need to get how long AB is. So this goes back to what we've been doing in class, that I'm going to do, this is a semicircle, so 180 minus 120 gives me 60 is my actual arc length. And then divide by 2, and I get that x equals 30. So once again, I had to go from the fact that BC is 120 to give me that AB equals 60, and then can use my formula. Sometimes we have to do stuff with expressions. So I have my inscribed angle and the arc it intercepts. So this one I have the information that I need. So 2 times my angle equals the intercepted arc. So 2 times my angle is 86 equals my arc, which is 1/3 9x plus 3. So that's going to be 86 times 2, 172 equals distribute 3x plus 1. So that'd be 171 equals 3x, which is going to give me 57 degrees. 3 and 4 have to do with the fact that if I have two inscribed angles that intercept the same arc, then those are congruent. So looking at this, I know that 1 and 2 are going to be congruent. So what do I have in this information? They give me that ST is 72. I want to find the measure of angle 1 and angle 2. So I'm just going to focus on this one right here. 2 times my angle equals my intercepted arc. So 2 times angle 1 equals 72. So the measure of angle 1 is going to be 36 degrees. So the measure of angle 1 is equal to measure of angle 2, which is 36 degrees. All right, so this one we're getting a little bit more complicated because we're going to have to go in the other direction. In this problem, first we need to see where are these angles I'm talking about. I'm talking about angle 1 and angle 2. Now, those are intercepting the same arc right here. Do I know what those values are right now? No. So one strategy would be to think, well, if I knew all but that one, I could add and subtract from 360. But I don't even know all the rest of the arcs. So here we have to use what we know about chords, which is that if I have two congruent chords, which they've marked for me, then that means that their arcs are also congruent. So since this one is 125, it also means this missing one is 125. And now I can add and subtract from 180 to get, I'm just going to call it x, to get my red one there. So I have x plus 125 plus 125 plus 55 equals 360. 250. So I'm going to do 110 minus 55. So x is going to be 55. And then 2 times your angle equals the arc, and my arc is 55 degrees. And divide by 2, that means angle 1, measure of angle 1 equals the measure of angle 2 equals 27.5 degrees. When I look at this one, I have my angle, and it's intercepting a semicircle. So 2 times my angle equals the intercepted arc. 2 times x equals 180, so x equals 90. So that's how I could do it mathematically if I don't remember the steps, or you can just have it memorized when it intercepts a semicircle that it's 90 degrees, which is what I need to be able to do here. So you want to see something like this. I see a little triangle. Okay, and this top angle is intersecting my semicircle, so I know that that means it's a right angle, or it's 90 degrees. And now that I have that that's 90 degrees, I can add everything together and set it equal to 180. So 2x plus 9 plus 4x minus 3 plus 90 equals 180. So 6x plus 6 equals 90. 90 minus 6, divide by 6, and I get that x equals 14. The last one we have to talk about are quadrilaterals. So with quadrilaterals, opposite angles are supplementary, so add to 180. So I have, in this one, I have 70 and y are opposite angles, so y plus 70 equals 180, which means y equals 110 degrees. Then I have that x and 55 are opposite from each other, so x plus 55 equals 180, so x equals 125 degrees. And if you think about it, it makes sense because these inscribed angles are half the intercepted arc, and so between these two angles I've covered the entire circle, which is 360 degrees, but since it's inscribed I have to divide by 2 to get 180. So it makes sense, but it would take you a while to get there if you don't know these properties. Okay, I have x, and then that's opposite angle 5x plus 24, so x plus 5x plus 24 equals 180, so 6x plus 24 equals 180, and 180 minus 24 is 156. Divide by 6 is 26.